Finding Stonehenge. I have often read and heard speeches on the conquest of fire and the invention of the wheel. All are agreed that these events were milestones towards the goal of human knowledge and civilization. In the contrary, no one speaks of the conquest of time, although it has been the subject of much attention of philosophers and scientists. There is no doubt that every knowledge fits into the time, and that no civilization is possible without the time. I will try to describe with pictures and comments the secular path of the people of Stonehenge towards the conquest of time. Even other peoples have made a similar path, but I think that the people of Stonehenge deserves a prominent position. The alternation of day and night is the most obvious and immediate perception of the flow of time. Having first capacity of numbering events or objects of the same nature, everyone can assess the duration of an event piling stones, one for each day. At first sight all the days seem the same point. No day is the beginning and no one is the end of a certain period, unless the event in question. In this way, each event is a defined time, but no event is in the time, because no event is contained in some other more extended. In other words, that people had the measurement unit but not a common origin of the time for all events. In the contrary, the nights appear distinct from a different perception due to the lunar phases. Two successive full moons are the beginning and end of a set of days. All people may easily observe these events. The people of Stonehenge began counting the days between two successive full moons, placing a stone at dawn after a full moon, and at dawn of each day thereafter until the next full moon, the beginning of a new pile. This practice was useful for breeding and farming, and thus became current use. Note: the animation shows a complete revolution of the moon around the Earth, i.e. the sidereal month, 27 days 7 hours 43 minutes, seen by an observer fixed to the fixed stars. Because of the rotation of the Earth-Moon system around the Sun, the synodic month, that is, the time between two successive alignments Sun-Earth-Moon, is longer. The figure above linear, seen by a terrestrial observer, is correct. The animation has a value of example and I think simple and useful to understand. In order to avoid disputes, it was necessary to have an official time of the community. This task was entrusted to trustworthy people, perhaps priests. All people observed that successive piles were composed of 29 or 30 stones, almost alternately. That advised a bi-monthly organization. The surplus of one day suggests to base the count in 29 days, 28 aubrey holes plus a station stone, or me, adding an extra day when necessary, that is, when it is observed that the moon is late. The month begins at dawn next to the observation of the full moon. The indicator, a pilgrim, is on station stone A. At the dawn of each successive day, the pilgrim is moved in the successive aubrey hole. This month is 29 days. The station Stonehenge is ignored. "29 days have elapsed. The first month of the current bimester has passed. At dawn will start the second month. This month is 30 days. The station Stonehenge is used. This day is not numbered but named, as that of full moon, and perhaps festive. A bimester has passed, and the new will begin at dawn. As mentioned, this day is not numbered but named. If we do that also with the 30th day, then the month will appear composed of 4 weeks of 7 days. The conduction of the calendar does not require knowledge of astronomy or calculations, but careful observations and experience, because the motion of the moon in its orbit is complicated and non-uniform. This calendar does not have New Year. To this end, the moon does not offer any help. We see the positions of the sun at dawn, in the line of horizon. Positions of the sun at dawn in 1 year. The position of the sun at dawn changes day by day. It is easy to see how the shadow cast by a gnomon changes every day. The summer solstice is easily determined by observing the change of the rotation direction of the shadow. The heel stone was placed to allow anyone to observe the summer solstice. Let's see how it works. Easy but careful observations allow to determine also the winter solstice and equinox. The people of Stonehenge now has references to fix the beginning of the year. The cycle of the sun cannot be accorded with that of the moon. To keep count of the days following the phases of the moon, the beginning of the year is fixed to the first full moon after the summer solstice. The beginning of the year and its duration, 12 or 13 months, both are fluctuating. This calendar is difficult from the theoretical point of view, but its conduction is not very difficult, as it is based on precise observations. This calendar is similar to Hebrew, only the references change. The journey described has took many centuries, and it was done in the late Neolithic period, more than 4,000 years ago. There is no discontinuity. Now at Stonehenge blows wind of revolution. The keepers observed that between 2 successive solstices there are 365 or 366 days. The month becomes constant and equal to 30 days. The organization is maintained bi-monthly. After 6 bimesters, 5 or 6 days are lacking to the end of the year. These days are public holidays and the next solstice will tell if they are 5 or 6. To do this, the 30 plus 30 holes Y, Z and the 5 hex stones are used. The 5 hex stones have a place available. The new calendar is solar only. Some argue that the said Y consists of 50 holes. It is clear that the organization bi-monthly is no longer useful, except the habit. You cannot configure a possible use of 50 Y holes, except for the computation of the year of Jubilee. It sounds a bit risky, but the structure of the old lunisolar calendar was maintained and breeders and farmers continued to use this calendar. Both calendars allow you to define and report the flow of time at the turn of the days. It is natural to attempt a way to regulate the flow of time during the day, between sunrise and sunset. As for the month and for the year, even for the day it serves firstly an origin, the beginning and end of each day. To do this, we observe the shadows cast by a gnomon during the day. The sun's apparent path shown in the figure is that of the sun at Stonehenge in a day of equinox, but what will be said is true whatever the day and place. The local meridian is the ideal circle passing through the poles, north and south, and the zenith of the observer. The true noon is the moment when the sun crosses the local meridian. In this position the sun has also the maximum height of the day in the horizon. At the true noon, the shadow cast by the gnomon has the minimum extension of the day, whatever the place and the day. The shadow cast by the gnomon lies in the projection of the local meridian, whatever the place and the day, and therefore it has always north-south direction. The people of Stonehenge devised a simple way that allowed everyone to observe the true noon. Not only you can tell the time at which the sun is centered in the door, but also what is missing or has passed since that event. This, of course, within the limits of the range controlled by the door. The game of the door of true noon can be repeated whatever the direction. The day begins at noon and is divided into 30 parts, as the month, 1H equals 48. Stonehenge has the limits of each sundial, but it is unique. This is Stonehenge in its time of greatest splendor. I'm sorry, the story does not have a happy ending. At that time, fleeing from bloody tribal wars, many people have crossed the English Channel invading the actual England.